We'll begin in this chapter with quite a few definitions just to lay the groundwork. Let's start with our basic idea. Is the study of how to collect, organize, analyze, and interpret numerical information from data. In this video, our focus will be how we can collect data in different methods. Before we go to the different data collection methods, let's first review the definitions of sample and population. A population describes all the objects or people you want to draw conclusions about. Now this is our focus, this is what we're interested in. However, if our population is extremely large, for instance, if we wanted to make a study about some aspect of people in the United States, we of course could not survey every single individual in the United States. So then when it comes to statistics, if we want to know about large groups, we now look at a correctly found sample of the population, and the sample of the population is what we can study because it's a more manageable size. So as y'all can see in the diagram below, here we have our entire population that we're interested in. We can't ask the questions to everybody in the population, so instead we select a sample of individuals, and this sample of individuals is going to be what we're going to study to make conclusions about the population overall. So just in quick conclusion, remember population is the larger original group, and then sample is the smaller group from that we're studying. So here in this example, if we're interested in the average weight of a particular deer species, then all the deer of that species are our population. However, we can't measure all the deer in the given population. So instead, we might be able to find a sample of 100 deer in the area to weigh and find their average weight. The average weight of these 100 deer that we found is information about the sample that we can then expand out to generalizations about the population. So we know that whenever we're studying a population, we need to select a smaller sample that we can look at or study. But how do you pick that smaller population in an unbiased way? We're about to go over a variety of different sampling methods where we'll discuss how you can gather a sample from the overall population. The first is simple random sampling. In simple random sampling, each sample of the same size has an equal chance of being selected. The way you could think of an example for this is, so in our example of simple random sampling, suppose there's 200 employees in a certain company. The Human Resource Department wants to draw a simple random sample of 30 employees to fill out a questionnaire about their attitudes towards the job. This would be an example of a simple random sample. Now, how could you figure out that it's a simple random sample? First, the idea is each one of the 200 employees has an equal chance of being selected. And although it didn't mention this, it's implied that if they're getting a random sample, since everybody has to have an equal chance of being selected, one way that could occur is you could list all the employees from 1 to 200, and each employee's name is now associated with the number. And then you could either pick 30 numbers from a manual way by putting all of these pieces of paper into a box and then selecting 30 random pieces once it's been well mixed. Or if you had access to technology, you could use a computer to generate from the numbers 1 to 200, 30 random numbers. The 30 employees' names who come associated with those numbers that we've selected would be the employees who fill out the questionnaire. So that's our idea of simple random sampling. Our next example is stratified sampling. In this sampling method, you divide the entire population into distinct subgroups called strata. And then all the members of the strata share specific characteristics to each other. Random samples are then drawn from each strata. So our example of this is a high school naturally has 100 freshmen, 120 sophomores, 90 juniors, and 105 seniors. Freshmen, sophomore, juniors, and seniors are the strata in this group. Now, the cafeteria wants to draw a sample of 90 students to ask their opinion about the new lunch menu. So from 90 students in all, They draw a random sampling of 20 freshmen, 30 sophomores, 18 juniors, and 22 seniors. So when we're thinking about stratified sampling, it's simple random sampling, but not over the whole population into the subgroups called the strata. In this case, if we were taking a random sample of just the total students at the school, if it was just a simple random sampling, you could end up in a case where all the people selected were from one or two of the age groups. However, in stratified sampling, we've ensured that there are people who are commenting who are freshmen, people who are sophomores, juniors, and seniors. So we can ensure that we get a representative of all the different stratas of the data set. Next up is systemic sampling. In systemic sampling, you arrange the population in some kind of ordered list, so each item has a particular number associated to it. And then once you have that ordered list of the population, you pick a random starting point, and then every kth member of the population becomes your sample. So our example for this type of systemic sampling is police at a sobriety checkpoint could decide to pull over every fifth car to determine if the driver is sober. So every 5 car that passes, that's what they take as their sample. Now, one important thing to note is that it is key that you have a random starting point. Otherwise, there could be some bias. So what does a random starting point look like in this example? The random starting point could just be the police arriving at a random time, right? And then saying, from now on, every fifth car, I'm going to check for sobriety. But you wouldn't want to say, okay, starting from this blue car, then it's every fifth. That could contribute bias to the situation. Next up is cluster sampling. In this, we divide populations into clusters, which you can think of as just groups, and then randomly select some of the clusters. Now, from those selected clusters, every person in that cluster becomes part of the sample. So the one thing that I want you to keep in mind is we've learned two different sampling methods that deal with groups, stratified, which had strata, and this cluster sampling. And the difference between those two is in stratified, you pick a random sample within the strata. You're not getting everybody from the group. However, in cluster sampling, you don't pick every group, but every group that you pick has all the people included in the sample. So our example here is officials at a Metropolitan Transit Authority want to get input from people who use a certain bus route about a possible change in the schedule. Of the people of the different bus routes in the week, they select 5 buses during the week, and then they poll all the riders on that bus about the change. So in this example, there are many different bus routes, and we couldn't ask all the bus routes and all the people our questionnaire. So instead, the buses or the bus routes become our clusters. And of those various clusters that we have, we picked 5 of them. And of those 5 clusters or 5 buses, all the riders on the bus were asked about the change. So the key thing with cluster sampling is it divides it into different groups. You randomly select some of the groups, but then all the members in that group get polled. Up until this point, we've been looking at unbiased sampling methods, and we're about to introduce 2 methods that do have bias within them. The reason that we want to talk about these is not that we say that you should run your samples in this way, but you need to be aware of them. So if you in our class or in your daily life see an example of bias sampling, you could know to take the conclusions with kind of a grain of salt because you know there could be bias within how you collected the sample. So again, convenience sampling, write down, is a bias method. It's not a method that we want to go through, but we want to be able to recognize it. In convenience sampling, you just use results that are readily available. There's no attempt to be random, there's no attempt to gather it in an unbiased way. Our example of this is all customers who entered a store on a particular time were given a survey to fill out concerning their opinions of service at the store. This is a convenience sampling because you would be drawing conclusions about all the customers based on the customers at a particular time. And you could imagine the customers who are there at 8 a.m. might have a different opinion than the customers who are there at 11 p.m., right? Depending on the store. So this is an example of a bias sampling. We would not want to take the conclusions from this and then expand it to the entire population. So our next sampling method that can introduce bias is the voluntary response sampling. And it's just using responses that are voluntary, so people volunteer to take part in the survey. So for instance, suppose we have a radio show host and he asks people to call in and voice their opinions on a new federal tax policy. That could create a bias sample because it's only getting the opinions of people who listen to the radio show, right? You had to be listening to the radio show and then you had to want to volunteer. So that's a voluntary response sampling. So keep in mind that the convenience sampling and the voluntary response samplings are examples of sampling methods that can contribute bias. Now, definitely, I could understand somebody's point of view that something's better than nothing, but if we're trying to make conclusions about our data set, we want to try to ensure that there's as little bias as possible, which is why we'll look at some of the previous methods, not convenience and not voluntary response. Now, let's go through a few more definitions. Although these definitions will expand as we learn more terminologies and more ideas related to statistics, let's start with the beginning definition. A statistic without the S. So remember, we're in the class called statistics, but this is just a statistic. So a statistic is a number that describes a sample. And there's going to be a really great way for you to remember that these two things go together nicely. Statistic starts with the S, sample starts with an S. Now let's contrast that to parameter. A parameter is a number that describes population. And these again go nicely together because parameter starts with P as does population. So let's identify which of these two, A or B, are a statistic or a parameter. 97% of carpenters in Florida are male. Now here, all the carpenters in Florida are a population. So since this is information about the population, we know this is a parameter. So the 97%, which is a proportion, is the parameter. It's giving us a number that describes the population. Now, in a sample of 100 surgery patients who were given new pain reliever, 78% of them reported significant pain relief. So here, in that we're looking at a sample, we know that this proportion, 78%, is a statistic about the sample.